Hey guys, welcome aboard to this video. We're going to be taking a look at a Leetcode question today, and the question is called valid parenthesis. Now for the description, we're given a string s containing just the characters that we have right here, and we're told to determine if the input string is valid. So we have two conditions. The opening brackets must be closed by the same type of brackets, and the open brackets must also be closed in the correct order. So what we're going to do is we're going to jump into a quick conceptual overview of this problem, and we're going to see how to solve it, and then later on we'll actually write the code to solve it. Yeah, so let's jump into it. Okay, so when it comes to the conceptual overview, the first thing that I usually like to do is to write down the question in my own words. It sort of gives me some clarity on how to approach the problem, and it helps me to understand it better. So that's what I've done in this first comment that we have up here. I've said that the function takes in a string of bracket characters, and these are the characters that we saw in the problem definition, and we either return true or false based on if it's valid. Now we have a couple of examples to sort of help us understand this a bit better. For the first example, we return true because in the string provided, the opening bracket matches up to the corresponding closing bracket. Therefore, this is a valid parenthesis. And in the next one, we also return true because for each of these opening and closing bracket, for each of the opening bracket, we have a corresponding closing bracket, and we're doing it in the correct order. Now for the third one, we return false, and that's because the opening bracket does not match up with the closing bracket. So these are two different characters, hence it's an invalid parenthesis. In the fourth example, this is where we sort of reiterate the importance of the order of the characters in terms of opening and closing the brackets. This right here is invalid. However, the valid kind of order for this one would be what we have down here. Now, taking a look at this example, we can essentially form some kind of a basis for what a valid parenthesis is. Now, if we take a look at these two strings that we have here, we can see that the latest opening bracket, if we encounter a closing bracket, then it must match up to the latest opening bracket. That's why in this first one, it's invalid, but in this second one, we have a valid parenthesis because the order is basically messed up in the first one, but it's correct in the second one. Now this problem, we can approach it and solve it using a data structure that's called a stack, which essentially follows a principle that is known as last in, first out. Because we know that the order is very important in us determining if a string is valid or not, therefore, having this principle kind of helps us to solve this problem. What this means is that as we loop through this string, which is actually what we're going to do, and we add the first opening bracket and the second opening bracket, we must match up. If we encounter a closing bracket, then we must match it up to the latest opening bracket. Therefore, the fact that we have a data structure that follows this principle will help us to solve this problem. So we're actually going to write down the pseudo steps to how we could solve this, and we'll actually pass down the function using this string that we have right here to help us to understand exactly what's happening. Okay, cool. So the first thing that we're going to do is we need a stack, which is the data structure that we are going to be using to maintain this principle that we have here, the last in and the first out. So we need a stack that's going to keep track of all of the opening brackets, and then once we encounter a closing bracket, we're going to match it up to the latest opening bracket in the stack, and then we'll determine if it's the correct one or if it's an incorrect one, and that's going to help us to determine if the string is valid or not. So we need some kind of way to also determine which are the opening brackets. So we're just going to have a string. We're going to create a string that will represent all of the opening bracket characters, so that when we're looping through each of the characters, we know which one is an opening one and which one is a closing one. The next thing that we need to do is we need to create a hash map that will help us to determine which character has which corresponding closing bracket. So if we have an opening bracket, then how do we know that this right here is its corresponding closing bracket? So we're going to use what's called a hash map to sort of map the opening bracket to its correct corresponding closing bracket. And then the next thing that we need to do is just to loop through the string that we're provided with. So if it's this one, for instance, we're going to loop through each of these characters that are in the string. And if it's an opening bracket, we put it into the stack. And if it's a closing bracket, we pop off the latest one from the stack and compare the two. So that's essentially how we're going to solve this. So I have a couple of more steps that I'm just going to copy and paste down here. So we're saying that if the current string is an opening bracket, add it to the stack. If it's a closing, pop off from the latest, and then we're going to compare the two. So if they don't match, then we're going to return false. Okay, cool. And then lastly, we're going to return true if they do match. So if we've gone through the string and we verified that each of the opening bracket has a corresponding closing bracket in the correct order, then we're just going to return true. Okay, cool. So let's actually write down the code, and then afterwards we'll step through using this string so that we can understand it better. So the first thing that we need is a stack, and we're just going to use an array in this example. So we're not actually going to build our own data structure. And then the next thing that we're going to do is we're going to create a string called opening brackets to hold up each of the opening characters. So this is an opening character, this one, and then the square bracket as well. The next thing that we need to do is to create a hash map that will map each of these opening characters to the corresponding closing characters. So let hash, and then I'm just going to speed through this. Okay, cool. So we've created the hash, and we're essentially saying for this opening bracket, this is a closing corresponding bracket, and so on for the rest of these characters that we have right here. Now the next thing that we need to do is to loop through the string that is provided. So essentially, if we're looping through this one, for example, we loop through each of these characters that we have right here. So I'm going to use a for loop. Is less than s dot length, and then I++. Okay, cool. So now that we have our for loop set up, now we can actually follow these other pseudo steps that we have down here. So we say that if the current string is an opening bracket, we're going to add it to the stack. So for the sake of simplicity, I'm going to store my current character into this char variable that we have right here. So that's the string at the index of I. Okay, cool. And then we're going to say if the current string is an opening bracket, then we're going to add it to the stack. Now, how do we know that it's an opening bracket? We essentially check the string that we have right here. So if opening brackets, and then we're just going to do a dot includes, and then we're going to pass in this character right here. So essentially the character that we're looping through, if it's in the opening brackets that we have right here, we're going to put it into the stack. So we're going to do stack.push, and then we're going to push in the character. Okay, cool. And then we're going to check if it's closing. That means that it's not an opening bracket. So if it's a closing bracket, we're going to have an else block down here. And what we're going to do is to compare the closing bracket to the corresponding latest opening bracket that's in the stack. So we'll only land into this else block, for example, in this string, if we encounter this character that we have right here, which is a fast closing bracket. Yeah. So what we're going to do is to first of all pop off the latest opening bracket. So we're going to say that let latest opening bracket, and then we're going to say that it's equal to the stack.pop. Okay, cool. So let me just reiterate that. Assuming that we have this as our stack. So actually I'm just going to do this. This is our stack. If we loop through the string that we have right here, we're going to have this first character, which is this, and then we're going to have this second character, which is this right here. And then when we encounter this closing bracket, it's going to be something different. So we're not going to add it to the stack because it's a closing bracket. But essentially what we're doing here, we're getting the latest opening bracket by popping from the stack. It will give us the latest added item to the stack. So we're going to remove that from the stack, and then we're going to have it somewhere right there, which is this variable that we have right here. The next thing that we want to do is to compare this latest opening bracket with the current character that we have right here. So actually what we're comparing it with is the opening bracket's corresponding closing bracket. So if we have this right here, what we need to compare the current character with is its corresponding closing bracket, which is what we have right here. So I'm going to say corresponding closing bracket, and we're going to say that that is equal to the hash that we have right here. So the hash, and then we're going to essentially take the corresponding of the latest opening bracket. So just to reiterate, if this is the character that we're looking at, we're going to come into the hash and look for this, and the corresponding closing bracket is this right here. So essentially this variable that we have right here, the corresponding closing, will be what we have right here. So this is the corresponding closing bracket for this. And then what we're going to do is to compare that with the current character that we are at. So remember that if we're in this string right here, we're in this character that's right here. Okay, so this is the first closing character that we've encountered. And we're going to say that if that character is not equal to this corresponding closing character, if they are not equal, we return false, because that means that it's not true. Now for this condition, if we're following up, remember that this right here was the corresponding closing, and then the character that we are currently at is also this character that we have right here, if you can remember. And we're checking if they're not equal. So if they're not equal, then we're going to return false. That means that if, for example, we had something that's right here, like what we have right here, we would have something like this. And therefore, this character is not equal to this one. Hence, we would return false, which is what we're doing right here, return false. Okay, I hope that this explanation, despite the fact that it's in depth, that it's actually making a bit more sense. So if they're not equal, we return false, which is the pseudocode that we have right here. If they do not match, we return false. Otherwise, we just continue and check the rest of the characters. So now, assuming that we've popped off that character, the next thing that's in the stack is what we had right here. Yeah. Now in the next iteration, we'll have a closing bracket yet again. Okay. So in that next iteration, we'll have something like this, which is what we have from the stack. So we're popping that off from the stack, and then we check for its corresponding closing bracket in the hash, which is this, and then we check that it's not equal to, so what we're doing here, that it's not equal to the character that we just landed at, which is right here. That's also going to be false. So essentially what I'm saying is that this condition will not return false, which means we'll just carry on with the code. Okay, so because we've reached to the last character, we've actually finished looping through it. And then lastly, what we do is we just return true. So we just return true if the condition did not return false. So that means that we have a valid parenthesis if we got to this point down here. Now there's actually one kind of edge case that we haven't covered, which is if the string that is provided only has just one character. So let's assume we only have this square bracket is what's passed in as this s. If we actually go through down the code, we'll find that we actually pushing it to the stack because it's an opening bracket. But we're not actually comparing it to anything down here because there's nothing to compare it to. It's just that one thing. And we'll find that we'll not even return false right here because we don't have a corresponding closing. We don't have a character to compare it with. But if we return true, that will actually invalidate our answer because this is not a valid parenthesis. We only have one character inside it and we don't have a corresponding closing character. Therefore, what we can do to cover this edge case is just check that the length is greater than 0. If it's greater than 0, it means that we had something in the stack and we did not pop it off. So which means maybe there's just one character that was added to the stack. Therefore, we're going to return false. That means that it is not valid. If that isn't the case, then now we return true. We have a valid parenthesis. So the way that we've tackled this problem is by essentially looking at any situation where we would invalidate the string that was entered. And if we run into any case of that sort, then we just return false. Otherwise, if we cover each of those scenarios and we still haven't returned false, then we return that we have a valid string. And that's essentially how we do this problem. So if I copy and paste this into Leetcode, we'll see that the code actually works. Okay, so I'm back here on Leetcode and I'm just going to paste my code right there. And then I'm going to click on run code. As you can see, the solution was accepted. And then if I click on submit, we can see that it actually passed all of the tests that we had. Okay, so that was actually this problem. In terms of the performance of this algorithm that we just wrote, we can see that the time complexity is just O of n. O of n, so it did 0 of n. So the time is O of n because essentially what we're doing is we're going through each of the characters in the string. So it's based off the string that we're provided with, and if we have more characters in the string, then we're just going to loop a more number of times, if that makes sense. And then for the space, it's also O of n. And that's because as we continue to loop through the strings, essentially we're adding stuff to the stack. So the stack could potentially grow according to the size of S. Okay, so I hope that you guys enjoyed this video and you actually were able to understand this question that we are tackling today. Until the next time, like and subscribe, and ciao.